looking to see how to prove or disprove something is onto. Okay, so let's think about this one. This is a line. Yeah, that goes over every y value, right? That's what we're looking at. If it's onto every y value in the codomain is hit. Okay, so it is yes. So what do we need to do to prove? So we need to say, okay, for every y in the reals, and that's the codomain reals, there is an x in the domain reals, right? Such that f of x equals y. Okay, so I talk about here about there's little scratch work to do. So this scratch work is like the contrived value. So this one here, I want to say, okay, y is equal to 4x minus 1. I want to solve for the x. So I get y plus 1 divided by 4 is the contrived x value. So what I say is I say pick x equal y plus 1 over 4. Then f of x will equal f of y plus 1 over 4. And then I apply the function. So it's 4 times that minus a 1, right? So I put in the y plus 1 over the 4. So that gives me y plus 1 minus 1. There it is, y. So I got there. So that shows that it's onto. Is this function onto? No, because this cannot hit all integers, right? This is not the line. This is just a bunch of dots, right, that follow the line. So something like this. So I can see that there's no y value. We're not going to get to the y value of 0. So I can say 0 is in the codomain. I'm just going to make sure we know that. But there is no x, I should say n, no n in the domain so that f of n, I want to write the function down, not f of n. I want to say that so that 4n minus 1 equals 0. This gives us n equals 1/4, which is not an integer. So that's why it's not onto. Okay, power sets, your favorite, I know. So let's think about what are the power set elements, right? Power set elements would be, well, we'd have the set A or the set B or the set C. Then we'd have A or B, and then B and C, and then A and C, and then A, B, and C, right? In order doesn't matter, so I don't duplicate those. And then the null set. Okay, so is this one-to-one? So this function it gives us the number of elements in A. So if I take f of this set A, it gives me 1. Oh, is it one-to-one? Let's think about it. So that's an element in the integers. But wait a second. If I take f of b, I get 1 also. So those are equal to each other, but the set A, does not equal the set B, so it's not one-to-one. Is it onto? Do I get to every y value in the integers? No. There's no set that has 5 elements, right? Or I could say there's no set that has -2 elements. So it is not onto.